Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and good morning to all of you. So our class will be start at 9. At 9. So we have another 3 minutes. Okay, can you see my slide?
Yes, can doctor.
All right. So at 10, some of you have a class, isn't it? At 10.
Yes, doctor. We have class at 10.
Oh, okay, right. So I try to finish on 10. Okay, right. So let's start our class today. All right. So Assalamualaikum warahmatullahi wabarakatuh, and good morning to all of you. So today we continue on our lecture for the simple neural networks. So we have another technique for simple neural network. Okay. So today we just cover for Adaline, Madaline, and also the Fukushima line. So I will try to finish on the 1 hour class. So to finish on the simple neural networks. So then next week, so we discuss about the example of every techniques. So today we just straightforward go for the Adalines, okay, Madalines, and Fukushima, because we are concerned of the time. And then I already give the exercise. So before this last week, so you can try lah. Okay, I already give exercise for perceptrons, Merkelov, and Herbs, and also the Madalines. So now we go for the ADALINES. ADALINE actually is the stand for additive linear elements. Okay, only one neurons involved of one neuron. Similar like Merkelov, Herbs, right? This is our S. Okay, X1, X2, X3, and so on. And then also some of the neuron we have the bias. Okay, these outputs. Right. So this means the Adaline is just only one element. Okay, only one neuron. So that's why we call the this stand for Adaline, additive linear elements. Okay, so this algorithm for Adaline. All right. First, you have to set up the neural network model. Okay, initialize the weights. Okay, initialize the weights. So normally that I mentioned to you, for simplicity, maybe you can set as the weight as the 0. Okay, bias is equal to 1. Okay, for simplicity. All right, and then also the set generate. Okay, for example, like our midterms or our final or our test, normally the weights, okay, the weights, random, bias and alpha is the linear rate will be given. Okay, will be given. No need to set lah. So it's not given, you can randomize lah, randomize the value. So for simplicity, normally we set all the weight will be 0, bias set as the 1 and then also you can set alpha rate to 0, okay, or and then the value lah or 1, okay, from 0 to 1 up to you. Okay, and then you can set the minimum error. Okay, so that's why you can set the minimum. So for example, error is 0.01. For example, you can set lah. So that means if error total less than error minimum, so then you can stop the iteration lah. So that is the condition that you have to set up the first, okay, for the Adaline. Okay, so we go for the step 1. Similar like with perceptron. Okay, you have to set activation inputs unit from U to X. Okay, so this is similar like with perceptron, right? So and then the next step you have to compute the net input, the S. Okay, so that mentioned is the same formula lah, B plus summation of Xi multiplied by Wi. So that is the standard formula to calculate the net input, the S, and then you have to update the bias and weights. Okay, you have to edit the bias and weights. All right, so this is formula, formula for adapt the weight for the line. So every technique they have different technique for adaptation the weights and bias. Right, so this one for Adaline, this is formula lah. B nu equals to B old plus alpha. Okay, alpha multiplied by T. Okay, T is target minus S. Okay, minus S. S is the net input lah. Alright, that the difference between the previous technique, for example, like perceptron on this part. Okay, so the rest is the same, but only this part lah normally difference compare than perceptron and so on. Okay, so the weight nu equals to weight O plus alpha multiplied by T minus S multiplied by SI. Okay, for example, this is weight 1, and then also this is also weight 1. Alright, and then so on lah. So until we have xn, so Wn, so this one will be xn. Okay, but so this one we have the stopping condition. Okay, some condition that you have to follow. If, okay, you can see what is the output here. If s greater or equal with 0, okay, then y equals to 1 lah. That means s greater or equal with 0, so our output will be 1. Okay, if less than 0, then the condition. All right, so either we can choose either 0 or negative 1. Okay, this one next I will explain to you. So you want to choose 0 or you want to choose negative 1. Right, they have another technique, how to choose the 0 or how to choose the negative 1. Okay, so and then the error will be the formula. So error is the T minus Y. Okay, T minus Y lah. So this is for error. And then you can see how to get the error. The E1, okay, that means the iteration 1 plus iteration 2. When every iteration you have to calculate the error lah. Okay, for example, after you go for the iteration 1, okay, go for iteration 1, and then after that you can get the T and Y, okay, get for E1. And then compare with E minimum. If greater, so you have to proceed for next, okay, for the next E2. Alright, so E2, if E2 plus E1 greater, so then you can proceed. Okay, until E less than E minimum, then we can stop the iteration lah. Okay, for example, that I mentioned to you. So our E minimums, maybe we can set such example 0.2 lah. Okay, the error minimum is 0.2. And then after you calculate the iteration 1, iteration 2, iteration 3 plus, and then error total will be 0.1. Okay, for example, that means 0.1, okay, less than 0.2 lah. So you can stop. That's if, for example, if we have 8 iteration, okay, 1, 1, 1, 1 is some example. Okay. 0, okay, 0, 0, 1, okay. So until the third iteration, okay, until E3, the error is less than error minimum, then you can stop here. Okay, we can stop here. No need to go for the next iteration for 4 iteration and so on. So, okay, just stop at the E3. Okay, because of the E minimum. Okay, sorry, E total less than E minimums. E total less than E minimum, then we can stop the iteration. We can stop edit the weight or bias. Okay, so that the condition that you have to know lah. That is for Adaline. The Adaline, we have the E minimums. You can set the E minimum, then every iteration you have to compare. For example, first we go for the first iteration. First iteration, the input 111, and then after you get the Y and T, so you have to calculate the error. So what is the error 1? And then after you get the error 1, compare with error minimum given. Okay, what is the error minimum? So if less, then stop. Okay, you can stop until iteration 1. That means then you can go for apply application lah. For recall phase. That means you can apply your networks to application. Okay, to solve the task. Okay, but if greater than E minimum, you can proceed for next. Okay, for next iteration E2. Okay, after you get the E2, also you can E1 plus E2, then compare with E total. Okay, compare with E total lah. This one maybe you can call ET lah, E total. So compare, if greater than E minimum, then you can proceed. Okay, proceed for next iteration. And there's some example here. After you calculate the E3, then plus E1 plus E2 plus E3 less than E minimum here. So then you can stop at iteration 3. No need to go for iteration and so on. Okay, just stop at iteration 3. That is condition that you have to follow lah. Okay. Right, so we go for the exercise. For example, right, so okay, we click here. So some example here. All right, so this is solved using the Adaline. Okay, first I write the formula. Okay, new with all plus alpha t minus s x. Okay, x lah, xi. Okay, okay, right, but yes, and then t minus s. Okay, so this is b new, b all plus alpha t minus s. Alright, so this is the formula to adapt the weight and bias lah. Okay, first we go for the first iteration. We go for the first iteration right here. So the input x1 1 1. Okay, first step we have to calculate the net input. So I calculate here. S equals to B is 1. Okay, given here B is 1 plus summation of S 1. Okay, 1, and then our weight 1 will be 0.1 plus input 2 is 1, and then our x2 W2 is 0.3. Okay, so the answer will be 0.1. Okay, 1 plus 0.1 plus 0.3 is 1.4 lah. Okay, so automatically y equals to 1 because s greater or equal than 0, so y automatically 1. So y equals to 1. So maybe you can put here lah. Another okay, s is the 1.4. Okay, so we can put another y here. Y equals to 1. Y equals to 1, and then check our t given here. T given here. So error. Okay, y over t. Okay, that is for error. Calculate the error. Okay, t minus y. T minus y. Sorry. Okay, the error. T minus y. Okay, so and then we can put another error here. So our t is a 0. Okay, y equals to y. Our y is 1. So negative 1. Okay, so negative 1 actually the error will be absolute. Absolute. Okay, that means our error will be absolute. So is the 1 1. Okay, so our E minimum 0.1. Okay, E minimum is 0.1. Okay, that means greater lah. So this error greater than E minimum, so we can proceed for the next. Okay, we can proceed for the next, but we have to calculate the weight 1, weight 2, bias. Okay, this one y here. Already put y here. Okay, well, and then just add the weight and bias lah. Alright, so weight 1. Okay, all is 0.1 plus alpha given 0.5. Okay, t 0 minus s is 1.4. Okay, and then multiply by 1 s1 1. Okay, that is for weight 1. And then weight 2 0.3, okay, plus this is same, okay, minus 1.4 multiplied by 1, okay. Then you can use your calculator to get this one, and then also the bias lah. The bias new, bias old is 1 plus alpha 0.5, okay, t 0 minus 1.5, okay. Then this is for new lah. Okay, this is already update. The initial will be 0.1, this is 0.3, and bias 1. Okay, so and then after that you can get something. What is the value here lah? Okay, you can try calculate here. And then you can get here error is 1. Okay, plus minus 1 because error is absolute error. So it's a 1. Then greater than E minimum. All right, so you can proceed for the next iteration. For next iteration, 1, 0, 1, 0. Our target will be 1. Okay, our target here. Okay, our target will be 1. The first step similar like same. You have to calculate the S. Okay, calculate the S, but make sure S. So the weight will be new one lah. Okay, add weights and bias will be refer this one lah, the new one. So for example, calculate the S will be B. Okay, B new sini after updated. So B new. Okay, you can try calculate after this. Okay, B new plus okay summation of XI. Okay, this is 1 multiplied by weight 1 already update here. So X okay plus okay X2 okay 0 multiplied by here already update here. So you can calculate lah. Okay, X assume as X. Okay, and then you can get the what is the S, and then after you get the S, get the Y. What is the Y? So the condition of S if so condition of Y. So if S greater or equal to 0, Y equals to 1. If less than 0, S you calculate for example. Okay, after you calculate this one, after you calculate this one, we get maybe we can get negative 1 for example. So automatically Y equals to 0 or negative 1 So this one, okay, this one I will show you. You want to choose 0 or you want to choose the negative 1. Okay, so we have option lah, but actually to refer this one, you have to follow the target. Okay, make sure follow the target. So you can see the target pattern here. Target pattern will be 0 or okay, will be 0 or 1. That means you have to select the 0. Okay, you have to select the 0 here. Okay, because of the pattern of target, pattern of the target is the only have the 0 and 1. So make sure you select 0. Okay, for example, if okay, for example, this one, if we have negative 1 and this one will be negative 1. So the pattern of T, we have the negative 1 and 1. All right, so if S less than 0, for example, similar like this is negative 1. So you have to select the negative because you want to compare. You want to compare T equals to 1. Okay, because if you select, for example, this pattern is a negative 1 and negative this one negative 1, but you select the 0. So when you compare with target, so that's why this is not same. Okay, this one is not same, this one's not same, this one not same, this one not same. Okay, that means Y not equals. Y not equal with target lah. That's why we have to set. Okay, so example, if you set this one negative, so this one Y here will be Y equals to okay negative T. This one not with T. This one not. Okay, this one yes equal to T. So that's why we have only 2 iteration that follow the target that follow target, for example. That's why if S less than 0, you can choose either you want to select the 0 or select the negative 1. This one based on our target based on T. Okay, based on T pattern. Okay, for example, given here our T pattern will be 0 and 1. So automatically if S less than 0, so automatically our output will be 0 lah. Okay, 0 make sure this one So rest you can try. Okay, this one we can try for the next iteration and then you can calculate the iteration. Okay, for example E. E1 plus E2. And then after you get all the value here, you just plus here, E total here. E total here, then you can compare with E minimums. Okay, if greater, so you proceed for the next. Okay, for the next iteration. Okay, calculate again until the fourth iteration. For example, fourth iteration still greater. Okay, still greater than E minimum. Then you can repeat again. Okay, repeat again for the next approach. We can call as the next approach. This one complete approach. Okay, after still greater than E minimum, so we can proceed for the next iteration lah. For the next iteration, that means for the second approach. Second approach will be same lah. 1 1 1 0 0 1 0 0. Right. So until you can stop until error total is less than 0.1. Okay, 0.1. That you can stop the iteration. Okay, that is for Adaline. Okay, next we can go for the Madaline. Actually, the Madaline, you can see this one. The Madaline is stand for multi-layer adaptive linear neurons. Okay, this is the combination of more than one Adaline. Okay, more than one Adaline. So you have to know the concept of the Madaline is similar like Adaline because of that is the take from the Adaline. Okay, this one but more than one more than one. Well, this is one Adaline, second, third okay, this is some example. Okay, that means the Madaline is the multi-layer adaptive linear neuron. Okay, that means more than one Adaline layer. Okay, this is some example of Madaline networks. Okay, so there is consists of 3 Adaline. Okay, 1 2 3. But the concept will be same. The concept, how to adapt the weight, how to adapt the bias, okay, the condition, okay, to compare the E minimum, okay, will be same, right? But normally for Madaline, okay, Madaline, they are assume error, ignore the error minimum, okay, they just proceed for the adaptation of the weight and bias. Ignore the, for this Madaline, they ignore the E minimums, okay. I will show you some example. Alright, so you can see this for Madaline. Each Adaline layer compute of ordinary Adaline algorithm. Okay, so that is a similar like Adaline, similar like algorithm. So the step will be similar. Alright, similar before this. Okay, so this one I will put skip. Okay, the weight between the hidden layer and output layer and the bias of the output neuron is fixed. Okay, fixed to 0.5. Make sure. From hidden layer to outputs layer, the bias or weight is fixed to 0.5. That means, okay, for example here, so this one, our weight equals to 0.5, weight to 0.5 is fixed, okay, 0.5, okay, 0.5 is fixed. It's not given for hidden layer to output is the fixed to 0.5. For example, here we have the bias. So normally here we have the bias, okay, we can set as the 1 or anything, any value are randomized. But for the second layer, for the hidden layer to output, this one will be fixed to 0.5. Okay, will be fixed. This one, weight, we have, for example, we have 8 weight, 8 layer for Adaline. So every weight, okay, every weight here for this one will be 0.5, will be fixed 0.5, will be fixed. Bias 0.5, weight also 0.5. Okay, but this one, the input here, okay, x1 here, actually is the output for y here. Okay, this one, for example, calculate this one similar like before this on the layer to get the y. So y here will be our input for this, okay, for this one. Okay, for example, this one, what you call y2 actually is equals to x2. Alright, so this one y3 equals to x3. Okay, this means the output here on this neuron actually is the input for next. Okay, for this neuron. Okay, for this neuron, for this element. Right, clear? This one, this output. Okay, this output for this neuron will be input for this one. Okay, for this one, and also this one. Okay, y2 equals to x2, y1 equal to x1. Okay, this means the output here, for example, after you calculate similar like Adaline, you get y, okay, s greater or equals 0, okay, y equals to 1. Okay, for example, after you calculate the s here, as we call it s1, you get the 1 point something lah. So automatically y equals to 1. So y equals to 1, this one, x1 will be, okay, will be 1. Okay, will be 1. So don't ask where is the input here, the input for this one. Actually, you already given, already given based on this one, the output here. For example, second, after you calculate the s equals to -1. So automatically y equals to, for example, the target is the pattern of the target 0 and 1. So you can select the 0. Okay, so the x2 equals to 0. Okay, x2 is equal to 0, this one, Similar like S3. S3, calculate S3, you can get 2. And then automatically y equals to 1. Okay, y equals to 1. Y equal to 1, that means x3 equals to 1. So automatically, so the output will be, input for this one will be given 1, 0, 1. Okay. Right, this one that I mentioned to you is fixed 0.5 from header layer to output layer. So the normally the maximum is 3 neuron 3 neuron in the header layer Okay, so then we can see adaptation of the weights. Okay, so if the output of the output layer is same as the target, no adaptation weight. So kalau if for example the output is same as the target, so no adaptation of the weight. But if not similar with target, you have to adapt lah. Okay, we have to adapt. Okay, for example, if the target is -1, okay, and then our y is 1, so not that all the value is not same with the target, so you have to adapt lah. If same, no need to adapt, but if not same, we have to adapt lah. That is the another condition for Adaline. Similar like this one Similar if our target is 1, so if our input on the first layer is the -1, so not same with the target. Okay, so we have to adapt. Okay, we have to adapt the weight and bias. Okay, so for adaptation of the weight and bias is similar like Adaline. Okay, the formula will be same. For example, weight new, okay, weight old plus alpha t minus s, okay, x, okay, s I. Okay, bias same. Every neuron will be same, same bits all plus alpha t minus s. Okay, that is the standard for Adaline. Okay, the bias and weight, the bias and weight, the formula bias and weight is the same with Adaline. Okay, so we go for some exercise. You can see this one, some exercise. All right, so already given here, so you can see this one. So the second layer here is fixed. This one is already given, okay, already given here. But if not given, so automatically you have to know lah. This one, the value here will be 0.5. 0.5 is fixed. Okay, it's fixed to 0.5. All right. Okay, so I will check the equation. Okay, so this is similar like this one. This parameter similar like this one. All right. So we go for the try. Okay, x1, 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 negative, negative, negative. Okay, so I will try another x1, x2, x3, and target. Okay, -1, -1, -1, and target is also -1. Okay, our target is the -1. Okay, so if you refer this target here, all right, so the pattern will be -1 and 1. So that's why our y, make sure you select the -1. If s less than 0, make sure you select the -1 because of the pattern. The pattern of target is the -1 and 1. All right, so you have to select the -1. Okay, but for the example, if your pattern have the -1, 0, okay, we have 0 here, we have 1 here. Okay, this one you can choose. You can choose either you want to select as the -1 or select the 0. The both is correct. Okay, for the pattern, if the pattern they have the -1, okay, for example, second we have the 0. All right, so that's you can select either you want to select the -1 or you want to select the 0. Okay, it's okay. The both is correct lah. Either you want to select the -1 or select the 0. But this one normally for simplicity I just give two pattern lah. Either -1 and 1 or 1 and 0. This means you have to select lah, either you have to select -1 or you have to select the 0. Okay, that is not for simplicity lah. Normally, for example, like for the midterm test or for the final, normally this way I already set lah. Either you have to select the 0 or -1. For example, this one you have to select the -1 if s less than 0. Okay, first you have to calculate the S1 here. S1 here, we declare as S1 here, S2 here, S3 here. Okay, for Madaline, will be take time lah. Maybe you can do the separate. Okay, for example, I do the separate for S1 here. I put S1 here. Alright, you can see. So the bias is 1.2. Alright, so you can see the weight here will be 0.4. Okay, weight 1 is -1. Okay, so next, make sure the same, the same. Okay, here will be for this one 0.1. Weight here 0.1, and then this is okay. The initial 1, -1, -1, and -1. Alright, so this one will be -1. Okay, -1 here. Alright, next will be here 0.6. Okay, next is 0.6. Weight is the 0.6, and the output will be negative. This one -1 -1, -1, this one -1. Okay, to get the S1 so the S1 equals to the bias is 1.2, okay, plus of summation of -1 multiplied by 0.4, okay, plus -1 multiplied by 0.1, okay, plus -1 multiplied by 0.6, okay, and then you get the S lah. Okay, you can use your calculator to get the S. Okay, okay, after yes, okay, negative. Okay, this one 0.5. Okay, 0.5, 0. Okay, I think 0. Okay, okay. S is the 0.1. S 0.1. You can use your calculator to get this one. So automatically y equals to y1 equals to 1. Okay, y1 equals to 1. So the output here, the output x here, we call as the x 1 1 I call as x11 equals to 1 Okay, this one for the next. All right. So next you have to do the for second S2. Okay, second similar. You have to because we have to solve until we get the S4, or sometimes we call it X4 here. We have to calculate the X4, then we can compare the target lah, y equal to target. This one So output here, the last output here, then compare with our target. It's not here. Okay, it's not here. It's not here. So for example, y equals here. So not compare here. So you have to compare output here. Y output. That's why you have to calculate the for X2 and X3. Okay, for example, X2 I skip for X2. Okay, similar like S1. Okay, the bias is 0.6 plus. Okay, so you can see this one. Make sure the same weight. Okay, this is 0.7, -1, 0.7. Okay, and then second is 0.8, -1, 0.8. Okay, plus this one, second is the 0.9, 81, 0.9. Okay, 0.9, 0.9, maybe here we get negative, negative something lah. Okay, negative 7, okay, 9, okay, maybe negative something. Okay, you can use your calculator. So automatically y equals to -1. For example, y, this one you can calculate lah. What is the value? For example, I put as the negative something, negative. So our output will be -1. Okay, so this one y, this one y1, y2 equals to -1. So our y x22 I declare as x22 equals to -1. Okay, -1 here. And then next you have to calculate the S3. Okay, similar like S2 and S1 S3. Right, so the bias 0.9. Okay, 0.9. And then plus 91 multiplied by 0.3. Okay, make sure the same here. 0.3, 0.2, 91, sorry, 91, the 0.2. Okay, plus here will be 0.7 negative 1 divided by 0.7. Okay, then you can get the what is the S. Okay, after you get the S, for example, this one I put as the negative. So I put as the negative like S equals to negative something. Alright, so automatically Y equals to negative 1. Okay, here Y3 equals to negative 1 will be input here. Will be input for X33. I declare as X33. So X3 will be negative 1, for example. Alright, so next you have to calculate, after you calculate S1, S2, S3, you have to calculate the S4. Okay, the S4, okay, I will show for the next is the S4. Okay, the S4, alright, so the bias will be 0.5. Okay, 0.5 and then plus, okay, the input will be 1. Okay, 1 multiplied by 0.5. Okay, plus, okay, this one will be negative 1 multiplied by 0.5 plus, okay, this one will be negative 1 multiplied by 0.5. All right, so you calculate this one, negative, negative, negative. Maybe you get the negative lah. 0.5, 0.5. I put as the okay, it's the 0. S4 is the 0. For example, automatically Y equals to 1. Okay, Y equals to 1. Okay, Y equal to 1. Because of S greater or equal with 0, then automatically Y equals to 1. So Y equals to 1. Then output here will be 1. Then we can compare with target. So our target is negative 1. Okay, so here you can see this one. Y is 1. Okay, our target is negative 1. So this one is not same. Okay, Y not equal with target. So we have to adapt our weights. Okay, we have to adapt our weights. Okay, this one. After we set this condition for this one. For this one. Okay, so which weight we have to adapt? Okay, you can see this one. Which weight we can adapt? Okay, either we have to adapt S1, S2, S3. All right, so here you can compare. Okay, after you get the SY here, the Y on the output, you can call YT lah. I put as YT or Y4 lah. Y4 compare with target. So you can see this one is not same with target. So we have to adapt. But which neuron? S1, S2, S3 yang that you have to adapt. So this one you can check. All right, so Y1 is 1, Y2 is negative 1, Y3 is negative 1. So that means only S1 which we have to adapt because of S1 is not similar with targets. Okay, because of SY is equal to 1. Okay, our target is negative 1. So for example, S2 our output is the negative 1, similar like target. So no need to adapt for S2. Okay, and similar like S3 is the output is negative 1, similar like target. So no need to adapt the S3. Only the S1 you have to adapt because of Y not equal with targets. Okay, right? So because of not equal with target, so only this means only this part. Okay, you have to adapt. This part, okay, you have to adapt, and this one, you have to adapt. This weight you have to adapt. Okay, this one, this one, 1, okay, 2, and 3, and also the bias lah. Okay, the bias. So this one we have to adapt. The rest no need to adapt. For example, this one, S2 no need to adapt. This one no need to adapt. S3 pun also this one no need to adapt. Only for the S1. So the S1 will be involved of this bias, this weight, and also this weight. Okay, right. So that is for first iteration. Okay, first iteration. Right. So next you can proceed for the next. Okay, for the next iteration lah. For Madaline, I mentioned to you Madaline. So no need to compare with E minimums. Okay, that skip the E minimum. Suppose actually if we follow the Madaline, so we have to calculate for E minimum for every iteration. For this one, because we want to show you how the weight and the bias is adapt. So we ignore the E minimum first. For Madaline, we ignore. Actually, for using the software, so using the MATLAB or something like that, the algorithm. So you have to every iteration you have to calculate the error and then calculate the error compared with E minimum. But for simplicity, for simplified the Madaline, so that ignore the E minimum, that you can proceed for the next iteration lah. Okay, for example, next iteration will be will be -1, -1, 1, and the target is the -1. Okay, you can proceed for the next iteration. Okay, next iteration, then after last at the S4, you compare with target. So if not equal, you have to add that lah. Which part you have to add that? Either S1, S2, or S3, right? And then go for the next, and next until we finish on the 8 iteration lah. Okay, this one we call the 1A push. Okay, 1A push. Alright, so actually for Madaline, for every we have E1, we call it E1, E2, E3, E4, P5, and every this one you have to calculate lah, T minus Y, T minus Y, and then compare with E minimum. Okay, but like I mentioned to you, so Madaline they ignore the E minimum first. Okay, so you can see this example I will show you. Alright, so that I mentioned to you S, okay, S1, okay, 0.1, okay, automatically Y equals to 1. Alright, so S2, -1.8, so automatically Y equals to -1, and also S3, -0.3, Y equal to negative. And then after you get here, the input here will be input for S4. This one S you can call as S4, ST, S total, up to you lah. Right, that's why you can get 0.5 negative, and then S4 will be 0. Okay, 0 greater than greater or equal with 0. That's why Y equals to 1. And then compare with target. So not equal. Not equal. That's why I mentioned to you. Only neuron 1 for S1 that you have to adapt. Okay, the rest no need to adapt. Only the neuron 1 you have to adapt. So the adapt you get like this 0.95, 0.65, 1.15, and the bias 0.65. Okay, so next you can proceed for second iteration. Okay, so I will show some example for second iteration. Okay, the rest will be same. You can see the rest weight and bias will be same. Only you can see only the S1 will be changed because of before this the adapt for only for neuron S1 So that's why again next iteration only this part the different because of the weight and bias already adapt. The rest will be same weights. Okay, the rest will be same weight and same bias. Okay, so for example, go for the S1. Okay, S1 0.5. Okay, this one you can try later on. Okay, so I just skip this one. Okay, got 0.2, so automatically Y equal to 1. All right, so this one, okay, 0, Y equals to 1. Okay, this one, okay, 1.1, Y equals to 1. And then this is input for second. Okay, the S4 here. Okay, we call it S4 or S total, up to you. Right, so after calculate the S4, you got the 2. So 2 Y equals to 1. And then compare with target. So you can see Y not equal with target. And then which one? Okay, which one? All the S1, S2, S3 not equal with target. So this one, that means S1 we have to adapt, S2 we have to adapt, S3 we have to adapt. That's why you can see all neuron we have to adapt. That means we have to adapt S1, S2, and also S3. Okay, this why we have to adapt S1, S2, S3. That's why for the Madaline they have the too many steps. Okay, this one we have to adapt for every neuron. That's why I call here you have to adapt all neuron. Okay, all neuron. That's why you have to adapt S1. Okay, this one for S1. Okay, all neurons. Okay, this one for S2 and this one for S3. For every neuron and bias. Okay, bias you have to adapt. Okay, next we go for the. I will show for the just quick view for the next iteration. Okay, for the next iteration, -1, 1, -1, target is the -1. And then you can see this one. Okay, after you calculate, okay, all the weight and bias already adapt. New the just use the new one for the bias and weight. Okay, make sure don't use the previous. Okay, use the previous iteration. Okay, for example, this one S1, we got the negative negative 0.8, so y equals to negative. So y equals to negative, y equals to positive. And then this input will be output for this output will be input for this for S4 for S4, then 0, and then automatically y equals to 1. After you get y here, so we have to compare with target. So y not equal with target, and then you can check which one not equal with target. So this one, okay, same. This one same. This one only. That's why you can only neuron 3 is not same with target. Only only neuron 3 you have to adapt. The rest will be maintained. The rest for S1, S2 no need to adapt. Only S3 you have to adapt. Okay, only S3 you have to adapt the weight and bias. Okay, that is similar like iteration 4. Okay, so for example like this one only only S1 this one maybe you can put as the S1 S2 lah. Because of the target is -1, so this one will be same, but S2 S3 you have to adapt lah. That's why you put this one S1 S2 you have to adapt adaptation on the S1 and S2, so no need to S3. Okay, for example I will show for if y equals to t. Okay, this one also y not equal with t. This one this part y not equal with t, so you have to compare. So this one all the neuron we have to adapt S1, S2, S3. We have to adapt the whole neuron. Alright, I will show you. Okay. Alright. For example, this one okay, this part only this part. After you calculate the S1, S2, S3, and S4, and then you get the Y total. Alright, so compare with target. So no adaptation If Y equals to T, no adaptation with and bias. So no need to adapt the Y bias Even for example, this one is the positive. Okay, for example, this one is positive. Okay, but our output here will be same. Our output is the y equals to t. So no need. Even this one is a 1. Okay, even this one is 1 not similar with target. No need to adapt because of the output on our neuron is similar like target. So for every S here, no need to adapt because of, for example, even this one not similar with target. Okay, no need to adapt because the output will be same like target. Okay, same with target, so no need to adapt for S1 for example, for S1 because S1 not similar with target. But for the output here, y not equal with t, so this part you can check either which one you want to adapt, this part or this part. Okay, one S1, S2, S3, which one not similar with target, then you can adapt which neuron you have to adapt lah. Okay, but if y equal with t, okay, y equal to t, so even this one not similar with target, so no need to adapt. Just use the previous just proceed for the next. Okay, next, for example, this is 6, so you can proceed to move to iteration 7. Okay, iteration 7, for example, like this one. Okay, iteration 7. Okay, this is y not equal this part, on this part not equal with t, and then compare which one not same. So all the neuron we have to adapt lah because not same with target. Okay, this is for iteration 7, and this one for iteration 8. Okay, iteration 8, for example. Okay, this one okay, y equals to t, so no adaptation of weight. For example, this one we have the -1. Okay, for example, the output here will be -1. So even this one is the y, the output will be y with y equal to target. So actually no need to adapt. Even for S3 is the -1, y equals to -1. No need to adapt, right? No need to adapt. Just remember just we follow this part. Okay, the output here. Okay, for example, we have Madaline here. Okay, consists of T1. Okay, this is a okay, only this part lah. That's why we compare on this part. This with target, not here. We not compare on the here on the hidden layer. We just compare with output and target. Then if y equal with t, no need to adapt lah. Okay, even on the S1 is not similar with target, so no need to adapt. But y is not equal with t, So, and then you can check either which one you want to adapt, S1, S2, or S3. You have to adapt. Okay, if not same with target, which one you have to adapt? S1, S2, or S3 lah. Okay, so this one you have the option lah. If Y not equal with target, so which one you have to adapt? So you can choose either the S1, S2, or S3. Okay, you have to follow. So for example, S1 and S2 not follow with target, so you have to adapt S1 and S2. So no need to adapt for S3. Alright, but if Y equals to T, so no need to adapt lah for S1, S2, and S3. Okay, that's all for Madaline. Alright, so I already give the example. Next, maybe next week we discuss about the example lah for every technique. For example, it's the McCullough and Pitts. Okay, Herbst. We have the perceptron, Adaline, Madaline, and last one is the Fukushima. I think the Fukushima also straightforward lah. Okay, Fukushima. This is I will show you after this the model of Fukushima, but this is formula for Fukushima. Okay, the formula of Fukushima lah is straightforward. Okay, this is formula to calculate the UJ. Okay, 1 plus summation of, okay, this similar like S1 WI lah, SI WI. Okay, similar. This one also similar lah. We declare as the XJ WJ. Okay, for example, this is I, this one for J lah, but will be same. Actually, it is same. Similar like S plus B plus summation of SI WI lah. Almost similar lah, but this one will be fixed. Bias here will be fixed to 1. Okay, and then this one, the rest you can depends lah, the input and multiply with weights. Okay, and then you have to minus with 1 lah. This formula lah, this formula for Fukushima, Fukushima. And then after you get the UJ, and then you can check lah. So this is condition, condition of the output. Okay, the output will be like this lah. Okay, for example, you calculate, you can get like this. So this is the output lah. So if our UJ greater than 0, then our output will be this one, UJ. Our output Y is the UJ lah. What is the value for UJ? For example, we get 1. So for example, 1 normally if UJ is greater than 1, so our output will be 1. Okay, otherwise will be 0. Then rest will be 0 lah. Okay, for example, less than 0 will be 0. Okay, so they have the excitatory weight and inhibitory weight lah. Right, so this is normally excitatory weight, that's the positive and negative lah. Okay, inhibitory, they have negative or positive weight. All right, so this is a model for Fukushima lah, simplified model. Okay, for example, they are separate. Okay, this one they separate for excitatory inputs. This one is inhibitory inputs. Okay, first let me show you, you have to calculate the EJ. Okay, this this formula, maybe I just give one for example. Maybe I put here is a 1. This is some example, just example to give you better clear for what is the Fukushima. And X3 I put as X3. Maybe I put as the 0. So the weight for this one, maybe you can set 1, 1, and 1. I put as the 1, 1, 1, 1. Okay, and then this one put as the 0, 1, 0, and then the by 0. Okay, set the 0. And this one 1. For example, this is some example. All right. So first step, we have to calculate the EJ. EJ. Okay. EJ similar like this one. XI WI lah. Okay. 1. Okay. Multiply by 1 plus 1 multiply by 1. Okay. Plus 0 multiply by 1. So EJ is 2. Okay. EJ is 2. EJ is 2, and then we have to calculate the HJ. HJ same. Okay, SJ 0, 0 plus 0 plus 0. So HJ is 0. Okay, substitute the HJ and EJ to this equation. 1 plus 2 divided by 1 plus 0. Okay, minus 1. So 3 minus divided by 1 minus 1. Okay, that means 3, okay, equals to 2. So Y equals to, this one will be 2. Okay, will be 2. Right. So because of our UJ here will be 2. So this one will be 2 lah. Then our output will be, if uj is more greater than 2, our y equals to 2. If otherwise, will be 0 lah. So this is the output, the output for Fukushima, right? Fukushima. Right, so that's all. That is for Fukushima lah. Fukushima is straightforward, just straightforward. Similar like Multilayer, okay. No need to adapt the weights and bias. This one no need to adapt the weight and bias because the output will be different. We have the linear line here, okay, the gradient, okay. So linear line. So this is the output. Not like for Fukushima, for Multilayer and PIT. Normally they have the 0 or 1, something like this lah. Okay, maybe on the, like a digital, so this one like a linear, okay, linear output lah, so that the difference of the another technique for simple neural network. For Fukushima they have the linear outputs, okay, linear output. But for the Multilayer, PIT, Adaline, Madaline, and perceptron, they have the like the digital lah, either 1 or either 0, okay, or either negative 1 lah, for example. That is for Fukushima. Okay, Fukushima straightforward. Okay, similar like perceptron. But this one no need to adapt the weights. For example, our weight here no need to adapt lah. Okay, no need to adapt this one. Normally we have only one input lah. Okay, but okay, every iteration they have changed the inputs lah. Every iteration. For example, we have before this x1, x2, x3, okay, 1, 1, 1. Next is 1, 0, 1, okay, 0, 0, 1. So they change on the inputs, okay, this one, but the weight will be maintained. Okay, the weight will be maintained here. The weight will be fixed out. If you fix as the 1 here, okay, this one also 1. All right, so everything will be follow. Normally the excitatory input is the positive weight, and this one inhibitory is the negative weight lah. Okay, for example, I put this one is the negative 1, okay, or 0 or negative 1. Okay, this is a negative. Okay, normally normally for Fukushima they separate the positive and negative weights. Okay, this for example for excitatory input, they put as the one input, and this one will be compared with another for negative. For example, negative weights. Okay, that's why they separate by positive and negative lah. Right, that's all for Fukushima. Alright, so okay, so that's all for simple neural network. So next week, similar like today. So next week on the Wednesday, so we try to refresh. Okay, refresh on the. So we try to some example lah. Some example on the Multilayer, okay, on the herbs, on the perceptron, on also on the Madaline, Madalines, and also the Fukushima. We try to do some exercise, some example of the simple neural networks. Okay, so after that we go for the backpropagation. So the last chapter lah. The last chapter for AI is the backpropagation. Alright, so I think we have another 1 minute or 2 minutes, okay, before we have stop here. So any question, guys? Okay, boleh? Okay, guys, boleh? Yeah, check here. Alright, so if no questions, so I will stop here. So see you next week lah. It will be same time. Maybe I will try to start in because of the we have to do some exercise. Next week we discuss about the example of every technique lah. To better clear understand for you what is the simple neural network, how it adapt the weight, how it adapt the bias. Okay, for every technique lah. We have the Multilayer, we have the we have the herbs, we have the perceptron, Adaline, and Madaline. Actually, Adaline and Madaline is the same concept lah. Refer as the Adalines. Okay, so Madaline is just is the more than one Adaline. And then another one we have the Fukushima. So normally we don't use the Fukushima lah. But on the class, I already explained how to use the Fukushima, but normally we don't use the Fukushima lah. Okay, because Fukushima then they don't adapt the weight and bias lah. Normally the Fukushima is, that's why the Fukushima is straightforward, also the straightforward lah. And then the output will be different compared than other technique lah. Right, so if no question, I will stop here. All right, so because of you have the class after this, okay, see you next week. Okay, thank you very much, and assalamualaikum warahmatullahi wabarakatuh.
Thank you, Doctor.
All right, welcome.